Okay guys, in this video we'll be talking about ecology, especially about the population ecology. Now I'm start making the videos about ecology and ecological sciences. Actually we can divide ecology in different parts like population ecology and community ecology and so on. And in my channel I'm going to divide this ecology lessons into three different segments. One is the basics of ecology, then we'll be talking about community and population ecology. Now this part of the series of video will be talking about the population ecology. Now before going into the details, you must know the hierarchy of ecology, and you can find this hierarchy of ecology in the basics of ecology videos, so in the introductory part about ecology. But now we will require that in a little amount. That's why I am writing the hierarchy of ecology here in the whiteboard. So we'll be talking about ecology. So population ecology, so it's called population ecology here. Okay. Now, the hierarchy of ecology is really important. Now, what we mean by the hierarchy of ecology, as we know, ecology is the subject to deal with everything that we see in the ecosystem, that is in the environment, and its relationship with each and every part of this ecosystem. That means ecosystem is consisting of biotic and abiotic factors, and all of these biotic and abiotic factors are in turn directly or indirectly are linked with each other, are working with each other. So there must be some relationship of these different organisms, or of different matters like biotic or abiotic factors. Now among so whatever we are dealing with here in case of population ecology are always the biotic factors of ecosystem. Now the biotic factor, among the biotic factor, the unit part and the smallest part of all is organism. Okay, it is called organism. So organisms are the smallest unit of all. Now if we combine lot of organisms, what we can make a total thing, a much more greater thing, or something which is greater than this organism, the limit is much more higher. It is called population. So what we can say is that if we take some organisms, for example, take the organism of, say, dogs. Now dog is an organism. If we set it, then many dogs, many species of the dog, if we combine all them together, we make a population. So among the population of dog, we are talking about only dogs, but there are different species of dogs. Now after that, if we add more and more population, what we can make is community. Okay, so many populations come together to produce communities. For example, if we take the population of dog, population of rat, population of, say, cow, all of them together we can make the community. So it's much more larger. So as we are going downwards, we are going towards the larger value. Now as we attach more and more communities, what we can produce, we can produce what we can say, so this is ecosystem, or yes, this is ecosystem. Now we combine more and more ecosystem, what we can produce, we can produce biome, and then what we can produce much more. So this is how we can go. So biome is much more large. Inside then we have the ecosystem, and in the ecosystem we are having the community, and the community are much more greater. So we don't require the latter things here. We only require this up to this level, the population. So we are dealing with this population in the population ecology. In the population ecology, we are talking about the different features of populations. That means features of those which are made up of same type of organisms. Now in this case, in this particular video, we'll be talking about the simple features of population, and we'll be talking about the growth of a particular population and how this growth is regulated. Now the growth of a population is very important thing to understand about this ecosystem, because we know that every ecosystem is having particular kind of factors like, say, different things are required for the growth and for carrying out the lifestyle, which are, say, the food source and also habitat. All of these things are required for sustain the life. So inside the ecosystem there are a certain amount of food source and also certain amount of habitats there. So if the population size is getting more and more increasing with time, and it cannot it may not be enough to get all the resources that are available. So we need to be very careful about the population size that that is actually regulating, that is actually determining whether this particular population is going to live on planet or not. Okay, so what we will be talking here is population growth, right? So we'll be talking about population growth. Now, what do we mean by population growth? Population growth means the number of individuals in the population start to rise. So it simply means the number of individuals start to grow up or rise, right? Number of individuals start to rise. It is called the population growth. So by which we can tell that this population is growing when we see the number of individuals of a population is getting higher and higher. We can tell that population is growing. Now when a number of individuals of a population start to go up, when we can find it? So the reason for that number of individuals of a population to get higher, the reasons for that, there are two reasons. One is high birth rate, and second thing is that low mortality. So these two factors are playing key important roles in increasing the size of a population, right? So if we think this as a population, so say this caps P is a population. Now two things are playing important role. One is the birth rate, another one is the death rate. Now two things are doing two important jobs. Now birth rate is increasing the population size. Death rate, if the high the death rate is, it is decreasing the population size. So I am putting the negative sign to the death rate. So these two factors are very important to regulate the size of a population. So this is the size of this population. Okay, now let us look at this factor. Now if we think, what do you mean by this birth rate or death rate? Now this birth rate and death rate is controlling the size of population. Now the difference between this birth rate and death rate can give us the rise of the population, right? Rise means the number of individuals getting increased over time inside a population. So what are the key points which are regulating the size of population? One is definitely two things. One is the birth rate and also the death rate. Over time, definitely if we don't put over time here, so it's over a particular amount of time, otherwise we cannot measure it, right? So whenever we are talking about rates, whenever we're talking about birth rate or death rate, we are talking about the number of individual or change in the number of individual with time, right? So suppose at the beginning we are having a particular number of individuals in a population, then after certain time we get a gain, and that is because of birth. So we can tell the number of newborn divided by that particular time to get this particular birth rate, right? So it is it will be called the birth rate. So what we know by the birth rate or death rate? So birth rate means, so from here what we can get, birth rate means number of individuals born over time divided by born over a particular time. So this part is really important. Over time, number of individuals born over a particular time divided by population size. This is very important to get the birth rate. And mortality means the death rate, which is also important. So in case of death rate, what we can get, number of individuals here, instead of born, it would be dead, right? So for calculating the birth rate, what we'll be doing, the formula is number of individuals born over time divided by the population size. For death rate is number of individuals dead over time by the population size. So that's how we can get our birth rate and death rate. Now suppose the birth rate is designated as, so this birth rate, so let me change the color. Suppose the birth rate is designated as small b, and the death rate is designated as small d. And we know how to calculate the small b and small d, because we can calculate the population size at a particular time. So definitely I need to write this again, at a, at a particular time. So this is really important, this time factor. So please keep track on this time factor, because this is really important. Okay, so we know how to calculate this b and d. Now if we know the birth rate and death rate, using them what we can get is the rise of the population. Remember, I've told you rise means the net number of individuals give or added or give a rise to a particular population, or added to a particular population. So what we can get here, so this is called the rise. So population rise per capita. So per capita means, again, now here again this birth rate and death rate, whatever we are doing, per capita, that means we are calculating into a particular area, a fixed amount of area. Now if you are calculating this birth rate for a fixed amount of area, say 200 square feet, and then you calculating the death rate of 300 square feet, this won't be result, right? So this type of result, we can't take this type of result because it was faulty. So we need to take the birth rate and death rate from the same amount of area, from the same location inside the ecosystem, otherwise we can't get the actual results, right? So we need to believe this fact, per capita. So it's a particular region onto which we are measuring the population rise, and onto which we are measuring the population size, and also the birth and death rate into this particular place. So the population rise per capita, we can write it as small r. So this is designated as small r, and it can be written as this. So it can be written as this small b minus small d. So this is the formula for the rise of a population per capita. Simply birth rate minus the death rate. Okay, so that is the gain, right? So net gain, what we are talking about, the rise in population means the number of individuals that are added to the population. So that means we are talking about the gain, net gain of organisms inside a population. How can we get that? If we minus or subtract this death rate or mortality rate from the birth rate, what we can get, the person that are added, the net person that are added. Now in a population, if, so there are three different factors. If small b is greater than small d, that means the birth rate is greater than d, so the value we can get, is positive here. So the value would be positive, that means we are having a positive rise, so the population will, so we can infer the population will grow. Okay, now another thing can happen, if say this death rate is greater than this birth rate. So in that case what we can have, we may have, definitely if this is greater, this d is greater than b, so we can have negative value, and a negative value means the population is not growing. So it is not growing, it is destroying. So it is not growing. And the third possibility that can happen here, this is if small b equals to small d, then what will happen? So that means the birth rate is equals to the death rate. It means the number of population size, the population size will remain same, because the number of individuals that are born is equal to the number of individual that is dies, right? So in this case what we get, the net value will be 0 in that case. So net value will be 0, and what we get, a population size is stagnant or constant value, constant population size. So this is very important. So this rise in a population is very, very important. Now whatever we are talking about here is definitely, I'm going to focus on to this part. Till now I have talked before like this population rise and population and all this, use the term population though, but this is not actually correct, because whatever we're dealing with, remember, high birth rate or low so birth rate or mortality rate or death rate, whatever we're dealing with everything. So rise per capita, birth rate per capita, and this death rate per capita. Per capita means we're taking small region and small amount of organisms to start with to look for the birth rate and death rate. So we are not yet apply this knowledge to a population. So that's why in that manner this part, or writing population in this particular equation is wrong. So I've written it to understand, to tell you, because most of the students made a mistake in this part. So don't think about this as a population, because we haven't applied into the population. Whatever we discussed till now is per capita. Mind it. Now in this case, from now on we'll be seeing if we take this and how we can incorporate this theory into measuring the rise in population. How can we do that? Now for that, what we can do to get the population rise, we can produce small rise like that, which is small r. So rise per capita. So in any kind of study, in case of population ecology as well as community ecology, whatever we're dealing with, if we try to find out the population size and its growth pattern and growth rate and all these things, the first important thing is to find out the rise per capita. And to get the rise per capita, we require the birth rate and death rate per capita, and we need to find that first. After finding it out, we will apply to this population size. So how can we get it? So suppose now we find the rise per capita, which is small r. Now the formula for getting the population rise, I am going to write the formula of the population, right? Now the formula for population rise per capita will be small r, which was previously we know, into n. N is the number of individuals in the population. This is very, very important. Remember, I've told you that until that part we cannot tell that this is a population rise. This is simply rise per capita. Now if you want to find the population rise, we can't write this. Then we can write the population rise. The formula for population rise is small r into caps n, where caps n is the number of individuals inside a population. Okay, so this is the formula of getting the value of the rise inside a population. So we can get the rise in population like that. Now this value is really important, because getting this value, it can tell us the important fact about population. We can look for the population growth patterns and growth dynamics using this kind of formulas. We'll be looking at it after a few times. Now another very important thing I must tell you, because before this discussion I have told you that two different factors are important in controlling the population growth. One is the birth and one is the death, but still another two factors play key roles, which may not directly have an impact, but that definitely had impact into population size, and those things are called emigration and immigration. Remember, like birth and death, if we think this is our population P, now birth rate can give addition. So if this is the population, so birth will add number of individuals, it will add, and also another thing which is called emigration will also add number of individuals to the population. In the other hand, two things are subtracting individuals from the population. One is death, which is subtracting number of individuals from the population. Another thing is also subtracting individuals from the population. It is called immigration, right? So immigration and emigration, they play really important role in controlling the population size. So I haven't mentioned them before, because the major criteria or major factors are birth and death, but also immigration and immigration are also playing important role in controlling the size of a population. So don't forget this concept. Just try to memorize this concept. Okay, so this is about the population, and we know population growth means the number of individuals are added ultimately at the end of a particular time into a population. So it's a net gain of individuals inside a population, and the calculation for that is to calculate the population rise. But to have the population right, we must first calculate the rise per capita, from which how can we get it? By subtracting the death rate from the birth rate, and then what we can get, small r, or the rise per capita. Then you can utilize this value of rise per capita, or small n, small r, and it will and multiply it with caps n, which is saying that this is the number of individuals inside a population, to get the population rise. Now once we get the population rise value, we can use it, and we know using this value we can get the number of individuals, or actually using this value we with time, definitely with time we can get particular value like that. Using this value we can actually plot graphs, and from the graph we can see during time, or through time, or with time, how a population is growing, or is it growing, or is it stabilizing, or is it falling down. We'll be seeing different videos. We'll be seeing videos of these different growth curves, and in those cases we'll be utilizing these formulas, small r, caps n, to actually get the values and produce the curves or graphs. Okay, so that's it, and I hope this will help you. Thank you.